We will now run the model. Go to the Run Simulation tab and click Run. The model was run successfully. Now let's go to the Results Summary tab. First, let's take a look at the zone conditions. As discussed before, this shows you a chart of the zone temperatures ranges throughout the year. And it also shows you unmet heating and cooling hours for the specific spaces. Thermal Zone 101 is our Apparatus Bay. You can see it has a large range of low temperatures, but the unmet heating hours is actually relatively low, only 40 hours for the whole year. This is because we have this Apparatus Bay set up as a freeze protection, and it's not set up for conditioning. There are times when the Apparatus Bay gets opened up and the fire crews leave and the large exhaust fan runs for several minutes while it evacuates some of the contaminated air. We don't have cooling in this zone, so you can see that there's a lot of hours where the Apparatus Bay is actually fairly warm too. The rest of the zones look fairly good. Some of the plenum zones do have some outside ranges of temperature, but those aren't the occupied spaces, so we shouldn't be worried about those. There is one zone that we might be worried about, though, is Thermal Zone 102. That's the decontamination laundry room. It doesn't have any cooling, so there are no unmet cooling hours, but you can see that there's a large range of temperature, large range of hours where it's greater than 88 degrees Fahrenheit. This might be something that we want to take a look at. If we want to diagnose this and find out just exactly where those hours end up, we need to rerun the model with some output variables. But first, let's go to the Thermal Zones tab. We're looking at Thermal Zone 102. We're looking at this wall heater here. It's good to rename these to something that you can identify when you look at the output information. So we have the wall heater labeled already, but we also want to label that particular fan for the wall heater and the heating coil for that wall heater. The exhaust fan is already labeled, so we're done with that. Next, let's go to the Output Variables tab. We're going to want to turn on an output variable for heating coil heat rate. And you can select different ways of outputting this information. Basically, these output variables are a trend log for whatever variable you choose, and it trends that information based on the time step that you choose throughout the entire run of the simulation. We will just leave the time step at hourly because that's what our simulation is anyway. Let's also select the site outdoor air temperature, dry bulb, we'll also select the zone air temperature. Next, we will save the model and we will go back and rerun the simulation. The simulation is completed. You can see that it took about 11 seconds to simulate. Next, let's go back to the Results Summary tab. And we will select Open DView for Detailed Reports button up at the top right. It's asking if we would like to display the trend data in imperial units. We will select yes. It has opened up the data viewer. Let's take a look at some of the data. Up at the top right, you'll see there's multiple tabs, and the first tab is hourly. We'll take a look at hourly dry bulb temperature and site electricity usage. We have selected hourly for both of these time steps. It looks like there is also a daily that we could select as well. It's a little bit less fine-grained. But at any rate, you can see that as the outdoor dry bulb temperature goes lower, our electricity usage goes up. As the outdoor dry bulb temperature increases, our electricity usage goes down. And that's because most of the facility is heated with electricity, but there are some small cooling systems that use some electricity during the summertime. Next, we can go to the Daily tab. And let's just look at dry bulb temperature hourly. Same thing. This is in day increments instead of hourly increments, but you can see that during the winter time, the outdoor dry bulb temperature is cooler. In the summertime, it's warmer. And you can also see that the daytime, during the day, it tends to fluctuate from high during the daytime and cool during the nighttime. And you can zoom in to see more detail if you wanted to see various months, or you can zoom to fit. Next, let's go to the Monthly tab. We will plot watt hours. Same situation. During the winter time, our watt hours are increased. During the summertime, we have low watt hours for the facility. Next, we will go to the heat map. For this, we will go to thermal zone 107 and take a look at this. This is the small office. This plots the temperature of the office this is the temperature scale during the hour of the day, and this is based on each month of the year. You can see that during the summertime, the office temperatures do tend to get fairly warm. In the wintertime, they stay in a tighter band, and at nighttime, when the office is turned off, the temperatures get cooler. You can also see that there are some days during June and July where the office actually does not cool off at nighttime. Next, let's go to there are various different viewing options that you can choose for this. And you can also adjust the ranges. Let's go to the Profile tab. And we'll take a look at outdoor dry bulb temperature. And you can see that there are multiple trends for this. And this is true for all the tabs. These trends are actually just the design day trends for sizing the system. The simulation runs through several iterations before it finally sets on the final run. So we're just looking at the run period. So let's look at run period dry bulb temperature, and we'll also look at facility electricity usage. You can see that it shows you in various different for each month, and you can also select annual to see the total year. Again, you can see that as the average daily temperature is lower, the watt-hour usage is higher. You can see that there's a coloration based on what the trend line is on the chart. You can see that the dry bulb temperature is blue and the energy usage is in orange. Any one of these tabs, you can download that information to a CSV file or an Excel file, or you can even copy it to the clipboard or save it as an image or a PDF. You can also upload CSV information for comparison to your model. I'm not going to go into that here, but there is a gentleman on YouTube that goes through this pretty good, Dr. Corey Budacek, and I will include a link to his videos in the description. Next, let's go to the Statistics tab. The Statistics tab shows you all of the average, minimum, and maximum information for some of the trend information. If we look at electricity for the run period, you can see our average electricity usage is 11,700 watt hours. Again, like I said, you can export this information to a CSV or Excel file or to the clipboard. Going to the probability distribution function and cumulative distribution function tab, PDF and CDF. On this tab you can look at where your data falls within probabilities. Let's take a look at watt hours again. You can see that this shows a range of probabilities that our electricity energy use falls within. So for example, during the summertime, we're going to have a low probability of using a lot of electricity. And on average, it shows that our electricity usage is about 11,700 watt hours, just like we saw in the Statistics tab. And then during the winter time, our electricity usage increases and increases And there's a probability of using 21,000 watt hours, but there's a lower probability because that only happens on very cold days in the wintertime. Again, you can export this information to a CSV or Excel file. Next, we can go to the duration curve. Again, we will look at watt hours. And this shows you hours equal to or exceeded. And you might use this information to determine rate brackets for electricity cost. And then finally, let's look at the scatter plot. We'll look at the dry bulb temperature, and we'll also look at the electricity usage. So you can see where the dry bulb temperature is on the bottom and the electricity usage is on the y-axis. And the scatter plot allows you to compare two different variables. And you can see that as the dry bulb temperature drops, the watt hour usage goes up. So you can do this for basically all the variables that you have trended using the output variables selection. So that's Data Viewer in a nutshell. Let's go back to the hourly tab, and we're going to try to troubleshoot that thermal zone 102. So let's select the outdoor dry bulb temperature. We'll get rid of this. And let's go to the 102 air temperature. And we can see that the zone 102 air temperature has a very drastic fluctuation. It always stays pretty much above 70, but throughout most of the year it gets up to 150 degrees or more inside that zone. Something is definitely going on here. Let's go to the electric wall heater, and we will plot this on the graph as well. You can see that the electric heater does run during the winter time, and it doesn't run very much in the summertime. Let's zoom in and take a look closer. You can see that the temperature gets hot and the electric heater shuts off. And it's almost like the electric heater comes on during the nighttime, but during the day the zone temperature gets very hot. So it must not be the electric heater. We also do have some other equipment in this laundry room. We do have a gas-powered dryer. Let's unclick this, and we will select gas. There. You can see that during the period when the gas consumption increases for this facility, the temperature in that room 102 increases. Let's go back to our model, and we will take a look at loads. gas equipment. This is our gas operated dryer. The BTU input for the dryer looks to be about right. You will see that the fraction lost is actually set to 0, which probably isn't true for this dryer. Most of the heat from the dryer is going to be exhausted from the building. It's not going to be lost to the space. So we should change this to 80%. Probably very little latent load, so we won't worry about that. This should solve our problem. Let's rerun the model. It looks like the model may have failed. Sometimes this happens though. Let's try to run it and see if it goes again. Okay, that worked. Sometimes you have to do that. I'm not sure why it does that, but sometimes if it doesn't run the first time, you might just try clicking the run button again. It completed in 6.5 seconds. Let's take a look at our results summary tab. Zone conditions. That's a little bit better. It looks like our zone conditions have gone down quite a bit for the high temperatures. We can look at DView again. Let's take a look at dry bulb temperature and zone temperature. Okay, our zone temperature is still fairly high. But you will recall that our previous run we had over 4,000 unmet cooling hours, and now we have a lot less than that, 300 or so. One of the things that we have to realize is that this space does have an exhaust fan that operates based on a user occupancy. We didn't do any balancing of airflow for this room, so this exhaust fan is actually probably not exhausting its full design capacity. It's probably only exhausting the infiltration rate of the room, which is probably fairly minimal. So what we need to do is balance that exhaust fan with the infiltration rate. And we will leave that at a different lesson. Thank you. Please like and subscribe.